segment, addition, postulate, and distance. Objective, I will use segment, addition, postulate, and distance formulas to calculate the lengths of line segments.
Awesome. So that's what we're going to be working on today. Make sure that you get your title and objective written down if you have not already. And let's just kick it off with the segment addition postulate. Again, postulate's something that you're going to take for granted. That is true. You're not going to really work too hard or think too hard about trying to figure out how to prove that it's true. We're just going to go ahead and be like, yep, sounds legit. The segment addition postulate says this. Given any 2 points, which we'll call A and C, we can say that a third point B is on the line segment formed by those 2 points. If and only if the distances between those points satisfies an equation. And here's the equation that it needs to satisfy. Look familiar? Yeah, where's it look familiar from? Yeah, from yesterday's stuff when we were talking about between. But let's look real quick back at yesterday's notes on between. Here's yesterday's notes, and I've just folded mine so I don't cover up the original notes. But if you want to flip back and look back at your notes on between, this thing requires that we know that the points are between before we can say that this equation is something that we can use. Where the segment addition postulate says, hey, if I've got 2 points and we've got some other point, I don't know where it is, but if I could somehow make it so that way these measurements all did what we asked them to do. Oh, this is oh, thank you. You're wonderful. If I can somehow, with these points somewhere, show that the left-hand side of this is equal to the right-hand side of this, then I know that that point B has to be on this segment. And if it's on the segment, and remembering that segments are only named by their endpoints, where does B have to be in relationship to these 2 endpoints? In the middle, somewhere between. It has to be this if we can get this equation to be true. So there's a real subtle, small difference between these 2 things. This notion of between says, if I know this point's between, I can use this equation. And this one says, if I can use the equation, then I can state that this point has to be on the segment, and therefore ends up being between. So it allows me to go back and forth between those 2 if I have to build this really strong logical argument and showing step by step by step things. Okay? Okay. Because segment addition postulate looks so closely related to betweenness, and because that equation is going to get used basically the exact same way, I'm not going to do any more examples on it. You've got it from yesterday. Y'all felt really, really comfortable with it. So we're just going to move right on to the very next topic. I'm adding a new, what's it called? A new thing to the notes. I'm going to put this horizontal bar to kind of break up big major topics so that it's easier for your eyes to track where things are. The next and final topic for the day is distance. We're going to do distance in 2 ways. We're going to handle distance on a line, and we're going to handle distance on a plane. Distance on a line starts with a line. and our 2 points. But this is one dimension. Right? Lines are one-dimensional things. They only have a dimension of length. And so our distance is only going to have one dimension to it, just the length. Can I get names for these points, please?
RM.
R and, what was it over here?
C.
And A, I heard in the back. All right. We'll be naming more, so those other letters that didn't get used, hang on to them. Be ready to shout them out when I call for more names. In the past, when I've asked for names and I said coordinates, you guys gave me numbers. But we want to generalize it. We want to make these formulas work no matter what numbers we're given. So we're going to use a variable to show that I've got some numbers sitting there. And I'm going to use x to represent the numbers for that dimension of length. But I need a way to state that these are different, because right now they look like they're the same value. They're both x. So we're going to use that subscript. You've seen this notation before?
Yes.
That subscript lets us say that this is the first x and this is the second x, and they're probably different. Maybe not, but probably. Okay. And so the formula for the distance between R and A, so we're using that subscript so that we can talk about different distances all in the same graphic, equals this vertical bar thing, and then taking the coordinates and subtracting them from each other. What are these vertical bar things?
Absolute value.
Lovely. What's absolute value mean? What's it do? Okay. She was commenting that it doesn't matter if what's inside this thing is negative or positive. It's going to become a positive. Yeah?
Yep.
Okay. So let's clarify it, make it a little more exact than just that. You're right, but we're just going to make it more exact. And I want to use this time to introduce a new note-taking symbol for you. It's a circle with little arrows on it to show that this circle is going around and around and around and around. And this symbol is what I'll use for recall information. It's a symbol to notify you that we're about to talk about something that you've already seen and should already have a fairly good handle on, but it's coming back again. Usually in the exact same format, in the exact same way. We're just applying it to something new. Okay? And the recall that we're going to be doing is absolute value today. As stated, we have our symbol for absolute value. And I'm using, in this case, the x to show that it is something. I don't know what it is. The absolute value then is defined as the distance a value is. Close the door.
I think I did my journal.
Your journal. Yes, I think you did too. I had someone pick them up and I don't remember. There. They're right there. The red and the green one.
Wait, I don't know. Where?
The spiral notebooks under their desks.
Oh.
Sorry, I got distracted by door and I started to write the wrong word. The absolute value is defined as the distance some value is from 0. And because distances can't be negative, like I'm 5 feet tall. That's the distance from the top of my head to the bottom of my feet. 5 feet. And if I managed to figure out how to stand on my head without killing myself, I'd still be 5 feet tall. Because it's a distance. This is a distance, that's why it always becomes positive. Because we're counting how far we need to go. Let's talk about distance on a plane. Planes, unlike lines, have 2 dimensions. So our little graphic has to start off this way. 2 lines looking like they hit at 90-degree angles to show that we have 2 dimensions. We have a length dimension and we have a width dimension. We're going to write the length dimension as x so that it matches our x dimension on the line. And we're going to call the width dimension y. And now this thing totally looks familiar from like coordinate, right? Yeah, fantastic. So now let's go ahead and put our 2 points on here. I need names, go.
M.
I heard M and Q. And we need coordinates for this thing. Notice this only had 1 coordinate. And how many dimensions did this have? 1. 1 dimension, 1 coordinate. The plane has 2 dimensions, so how many coordinates?
2.
And this is the reason you were taught this with X and Y. Because you have to say how far you're going in the length dimension, which we're calling X, and how far you need to go in the Y dimension, in the width dimension, which we're calling Y. All right, our formula for the distance between point M and point Q, again, using that subscript, so that way when we've got more than one segment going on, we can talk about distances of specific pieces. Okay. I need to focus on the formula writing, so I'm not going to talk while I write it, because I will get lost. Here we go. And I had to hold my tongue just the right way to make that all work. I'd like to point out something about the square root. Notice at the very end of the square root it has kind of this little tail thing. It really doesn't have a tail. Like if you type it up, it doesn't have a tail. But I've started adding one when I write it, because I found when I was doing this in high school and in college, I would get confused as to where this thing would end, and I'd have stuff fall out of the back, I'd have stuff magically appear inside of it that wasn't supposed to be there, because I couldn't tell where the thing ended. So I decided to put this little tail on it to be like, it ends there, don't mess with it anymore, okay? If you think that'll help you, because you're going to do a lot of that coming up when you hit Algebra 2 and others, please feel free to adopt. If it doesn't help you and you're happy with how you do it, that's fine too. All right. Feel comfortable on the formulas? Yes. Yes. The only thing that I want to say is, like these coordinates, we need to have an x1, y1, and an x2, y2. So you just pick and assign, and everyone is happy. Let's look at our study guide. I know, right? We only have 2 examples and then we're done, I promise. Take a look. The study guide has the formulas written down again, and my printer decided to chew the top part of the square roots everywhere you come across one. So if you would like to go through and write the bars on top of the radicals, that would be awesome. If you understand what it means without that top bar, that's okay. Read through example 1 and example 2. How is it feeling? Thumbs up on example 1, you know exactly where they got everything and what they did. Thumbs sideways, you're not really sure, you'd like to see me walk through. Vote now. ¿Lo entendiste todo? Okay. Thumbs sideways. Okay, I have a few thumbs sideways. So for those of you who are thumbs up, start reading this one. Those of you who are thumbs sideways, let's do this one together really quickly. All right, looking at the directions, are we in 1 dimension or in 2? Well, we're on the line, so we have to be in 1 dimension. So we're going to use the formula for distance on a number line, which is x1 minus x2 in absolute value. Now, we have 2 points, B and D. We get to assign which one is which. Let's make bx1 and dx2. So the coordinate of B is -7. And the coordinate for D is -1. And so far, that's what my substitution looks like. I'm going to simplify this a little bit. I have that double negative there that's kind of bugging me a little bit. Double negatives turn into an addition, and so I can exchange the minus -1 for plus 1. Looking inside the absolute value, negative 7 plus 1 is negative 6. And the absolute value of negative 6 is 6. Vote again. Thumbs up. This clarified. Do you feel better? Okay, thumb sideways. We're still confused. All right, fantastic. Thank you. You had a chance here, those of you who were thumbs up before looking at example 2. Vote again for me. Thumbs up. This makes complete sense. Thumb sideways. You'd like to see a quick walkthrough. Okay, I have a few thumbs sideways. Those of you who are thumbs up, if you'd like to start on the skills practice at this time, you're more than welcome to. Everyone else, here we go. Okay, don't talk yet because we're still on presentation. Number 9 says, find the distance between each pair of points. Looking at the points, how many coordinates have we been given?
4.
We've been given, okay, it looks like 4, but on each point. So if I cover B, we have 2, which means are we on a line or on a plane? We're on a plane. So we need to use the formula for distance on a plane, which is the one with the square root. I ask you please when you're doing this to rewrite the formulas each and every single time you're going to use it. Is it tedious? Yes. Will it set you up for success on some of the other things we're doing? Most definitely. We need to decide which point is x1, y1, and which one is x2, y2. Those of you following along, which point do you want to be x1, y1? A. Okay, A has been selected as x1, y1. This forces us to make point B x2, y2, and so we're going to go ahead and do our substitutions now that we know which point is which. When you are doing your homework assignments, you must show this level of step-by-stepness. Okay? I'm going to go ahead and zoom through the rest. You know where the substitutions happen. So right now I'm just cleaning up. I need to do the stuff in the parentheses first. I'll make that 8 a little better looking. When you're on a multiple choice item, a quiz or a test, I don't need to see the steps. You're welcome to work them out and you're welcome to show them on a separate sheet of paper and turn them in with your answer document. In case I have a question, I can look to see what you're doing. But on multiple choice, I don't need the work. On open response, such as your homeworks and your practice, I need the work. I'm making sure that you're understanding the process behind it. All right.